Okay, good morning once again. See, this is what we did last lecture. Now we're done dash.
Yes, we stopped here.
Okay, so now we need to do we were doing nucleophilic substitution reaction now. Nucleophilic substitution reaction. No need to explain, we did this in detail. So here in these reactions, a weaker nucleophile is substituted by a stronger nucleophile. I told you this one, okay? So all of you know this, I hope. See, in this particular case, the nucleophile X is replaced by the weak nucleophile X minus is replaced by the strong nucleophile Nu minus, and this is a reaction. So that is X is replaced by Nu. So this is nucleophilic substitution. And now it has two different mechanisms. One is SN1, the other one is SN2. Okay, SN1 mechanism. So the difference between these two, first in this case it takes place in two steps. Okay, so whereas SN1 it takes place in one step, just opposite. Look, SN1 takes place in two steps. SN2 takes place in one step. I'll tell you why is it called SN2 at the end. Okay, see, look, I told you it takes place in two steps, right? Step number one, formation of a carbocation. Okay, so the reactivity depends on the stability of the carbocation. So the first step is Rx. It is a slow step. You get R plus X minus. So here, this is the carbocation. So the reactivity depends on the stability of the carbocation. Can you hear me?
Yes, doctor.
Okay, so reactivity stability of carbocation. Okay, if a stable carbocation is formed, the alkyl halide will be highly reactive. So this is step number one. So first step, X minus is going. Now, second step is nucleophilic attack. So this is a fast step. So next step, what happens is R plus. Who is coming in? Who is coming in?
The nucleophile.
Nucleophile. So Nu minus. So what do you get? You will get, tell me, R and U. Okay, so this is the reaction. So this step is a fast step. Did you understand? It's very easy. Clear, no?
Yes.
Okay, so first step X minus is going, next step Nu minus is coming. Now, you studied this in physical chemistry. I mean, in Cheng itself, I think so. Rate of if there are two steps, if a reaction takes place in two steps, one of the steps is slow, the other step is fast. Rate of the overall reaction depends on which step? Yeah, of course, the slow step. Okay.
The determining step.
Yes, very good, very good. So you studied all this. Okay, so this is the rate determining step. Okay, so now can you tell me the rate law now? You know all these things. Tell me the rate law.
Rate first order?
Yeah, so rate of the reaction will be equal to K times rate constant K times concentration of the reactant in the slow step. So what is the concentration of the reactant in the slow step? This is the reactant, right? So it is Rx to the power 1. So what's the order of the reaction?
First order.
Order of reaction is first order. So that is why it's called SN1. Did you understand? SN1 means it is nucleophilic substitution. Order of the reaction is 1, or you can tell molecularity is 1. Order is 1. Okay. Is it clear for everyone? Understood? Did you understand, dears? Okay. So, whereas if it is the same reaction, if it is following SN2 reaction, it takes place just in one step, right? So here Rx plus Nu minus. So what happens is, same time, simultaneously the process will occur. It takes place in one step. So Nu minus is coming in, same time X minus is going out. So what do you get? You get Rnu plus X minus. Here the rate of the reaction depends on the steric hindrance. If the steric hindrance is less, reactivity is high. Okay, now what is the rate law here? Tell me. Rate is equal to, tell me.
K.
K.
Rx.
Yes, concentration of Rx to the power 1.
And the concentration of
yes,
Nu
concentration of
minus
Nu minus to the power 1. So the order of the reaction is equal to
second
1
order.
plus, yes, second order. So that is why it's called SN2. Okay, I hope you have an idea now. Yeah?
Yes, doctor, it's clear.
Now, so this is the same thing. Here, suppose if the molecule is a chiral molecule. If it is a chiral molecule, what will happen? Just a minute. SN2. We'll do first of all SN2 for a chiral molecule. Okay. After finishing SN2, we will do SN1. See, look here. This is, before that, I just want to tell you something. Can you see I wrote here S and here I wrote R? Okay. This S and R, it is actually related to stereochemistry, and that's from chapter 5. So that portion is cancelled from your syllabus. So you don't need to know how it is S or how it is R. Okay, so don't worry about it. Okay, understood what I meant? Don't. When you look into a structure, you will be able to know whether it is S or R, but it's not there in the syllabus for you. So don't worry about what I wrote S here. Okay. Now here, in this case, this particular reaction, this is primary, secondary, or tertiary. This alkyl halide I have taken is which one? Tell me.
Secondary.
Yes, secondary, because it's alpha carbon is attached to only 2 carbon atoms, so it's a secondary one. So now here the nucleophile is OH minus. Did you see? This is the nucleophile. Now this Br minus will be replaced by OH minus. So that will be the reaction. So how does it occur? See, look, this is something very important. Try to understand it. Now here, Br minus is the leaving group, right? The one group which is going to leave the reaction mixture. Now OH minus is the incoming one. So this OH minus, same time both of them are there. Okay, so OH minus is approaching this carbon, Br minus is going to leave. Okay, so you get a transition state where all 5 groups are there. Valency of carbon is 4. So now in this case, it's surrounded by 5 groups. It will be highly unstable. And now, so actually what happens over here is, to avoid steric hindrance, OH minus approaches the carbon at an angle 180 degree to that of the leaving group. Did you understand?
Can you explain that point?
See.
What do you mean steric
hindrance? Okay. Just a minute. I will tell you again. Suppose in a classroom, okay, This is a classroom, UOB classroom. In the classroom, there is a chair. This is a chair, just imagine it's a chair. One student is sitting there. I want to replace him. You understand what I meant? I want him to leave the class. Instead, I want to take another person in. Is it okay? Understood the meaning?
Yes, doctor.
Okay, so now here, one person has to go out, another person should come inside. Sah? So he is sitting in the middle of the room. He is sitting in the middle of the room. We have two doors, one door this side, one door this side. Okay, got? Understood what I'm telling? Okay, yes. So now, suppose he is going out through this door. So the other person, can he come inside through the same door?
No, it's going to be too crowded.
No, because Mafi place, there is clash. There will be clash, right?
Yes.
Yes. So what happens is, he is going out through this door and the new person will come inside through the other door, opposite door, to avoid steric hindrance. Now it's clear.
So the incoming group is going to come at the opposite angle of the leaving group?
Opposite. It's 180 degrees to that of the leaving group. See, look. This is the one going to leave. This person is going out. This person is coming in. So he is going through this way and the other person is coming in through the opposite way. Now it's clear?
Yes, doctor, thank you.
Okay, so this is what happening. So incoming group is approaching, I'll tell slowly, listen to that. The incoming group, that is the nucleophile, here OH. This OH is approaching the carbon, coming closer to the carbon at an angle. Oh, where is it? Okay. Yes, at an angle 180 degree to that of the leaving group. Okay, the Br minus is the leaving group, OH minus is the incoming group. So it is approaching this carbon opposite to that of the opposite direction. Is it okay? So this is the transition state. Is it clear? Is it clear?
Yes, doctor.
Okay, so now what happens over here is, this is applicable only for chiral molecules. You know what chiral molecule? If it is attached to 4 different groups. All are here in the class now. All my students, all are here, right? This is for a chiral molecule. So what happens is, when OH minus is approaching this one, its configuration is getting inverted. Look over here. These two are towards the left side, correct? These are towards the left side, and this is on the right side. Br is on the right side. Now OH is coming on the left side, and these groups are going to the right side. Did you understand? Did you understand?
This only happens for chiral molecules?
It's applicable only for chiral molecule. Otherwise, does not make any difference. Okay. See, you know umbrella, my dear students. You know what umbrella is? Umbrella.
Yes.
What is the Arabic word for umbrella? What's the Arabic word?
I don't know.
Anyone? Any of the students? Can you tell me? You know what umbrella? This is not a common one here. My dear students,
Madalla.
Sorry?
It's called madalla.
Madalla? Okay,
yes.
Okay. So this is umbrella. Just imagine. Suppose one day we have in Bahrain too much wind, you know, hawa, too much wind. You are going on wind and rain, okay? Rain is there, wind is there. So you are going out. It's very nice to see, no? So you are holding the umbrella and you are going out, okay? Imagine, okay? You understood what I'm telling, what I'm trying to tell?
Yes.
Okay, so now, suppose the hawa, you don't know because you don't get used to it, how to use umbrella and all that, you don't know. But we are from India, so we know we have too much rain. We know how to handle it, but you don't know. So what happens is, wind is coming this way. You understand? So you don't know how to do it. So strong Hava is coming and approaching the umbrella like this. What will happen to the umbrella? Come on, tell me.
It will flip.
Yes, it will flip. Okay, so this part will be like this, and then you will be holding like this. Understood what I meant? Understood?
Yes.
Okay,
Yes.
so that means you will be holding the umbrella with this, which it will be open in the opposite way around. Okay, and this is what happening here. Okay, yeah. So what happens is, look over here, the groups which are on the right side, in this case, here this is on the right side, BR is on the right side. So in the answer, OH is coming on the left side. Then look, this H is towards the left, here H is towards the right. CH2, C2H5 is left side. This is becoming right side. That means the wind is coming, it is flipping. Okay, so this is called inversion. What is it called? Inversion of configuration. So if this is S molecule, it will become R. So don't worry, in the exam, if I write S, you make it R. That's it. You don't need to know how it is S, how it is R. So if you start with SR configuration, it will become S. Similarly, if it is S configuration, you will get R. Similarly, if it is a cis isomer, it will become, trans, and trans will become cis. So that means SN2 reaction in a chiral molecule will result in
Inversion.
Inversion. Okay, did you understand now? Is it clear?
Doctor, I have a question.
Yeah, sure.
The rule about how the incoming group comes at an 180 degree for the leaving group, is it applicable also only for chiral molecules, or is it a general
it's
rule?
applicable for all molecules, my dear. It's applicable for all molecules, but the configuration will not change. We cannot tell R will become S. There is no R or S. So in that case, it does not make any difference. But the mechanism remains the same for everything. Even if it is a chiral molecule or not a chiral molecule, incoming nucleophile is always approaching the carbon at an angle 180 to that of the leaving group. Okay, all cases, but there is no question of configuration coming there. R or S or something is not coming. That's what. Process remains the same. Okay. You understand what I mean? When you write it, suppose instead of the CH2, just a minute. Suppose instead of this one, this also is CH3. The same process will occur. So this will become CH3 here. And the mechanism remains the same. But there is no R or there is no S. That's only difference. We can't call it as R or S. R or S only for chiral molecules. Now it's clear?
Yes, doctor.
Okay, yes. Now, the order of reactivity of SN2 mechanism, tertiary alkyl halide is the least reactive, then methyl halide is the most reactive. Can you tell me the reason for that? Can you tell me? Can you tell me? My dear students, the reactivity depends on the steric hindrance, right? If the steric hindrance is high, reactivity will be less. If the steric hindrance is less, reactivity will be more. Okay, so I will write it.
So the methyl halide is the least bulky. That's right?
Yes. Reactivity is inversely proportional to steric hindrance. I think you can read what I'm writing because on the screen it's not easy. I cannot write it neatly. Okay, I hope you can read it, right? Can you read it clearly? Yeah, yes. Because it's not easy to write. Steric hindrance. Okay, so Look here. Suppose we have a tertiary one. C, R, R, R. It can be same or different. I just wrote all of them. Okay, R1, R2, R3. It's same. It does not make any difference. Okay. This is tertiary. Correct? Tertiary alkyl halide. It's least reactive. Why? Steric hindrance is maximum. You understand? Because the incoming nucleophile cannot approach the carbon, alpha carbon. Why? Because it's surrounded by bulky people. Understand the meaning? Then next one is secondary. So it is, say, C, R, R1, say R2, H, X. So this is more reactive. Why? One group is small. The next is H, X, R. Now here the most reactive is methyl halide. Why? Because hydrogen atom is the smallest. You understand? So methyl halide is most reactive as steric hindrance is
minimum.
Minimum. Okay. Then other points. Aprotic polar solvents. Aprotic means Mafi proton, but it's polar. Example, I'll tell you. Acetone. See, this is a polar solvent, but it's not a protic. Aprotic means not protic. Aprotic polar solvent. Example is acetone. Acetone is polar, but it does not have any proton. It doesn't give H+. Now, to favor SN2 mechanism, the nucleophilic strength should be high. Okay, a strong nucleophile is needed. So you don't need to know which all are strong or which all are weak. You don't need. Okay, I'm just these are the conditions. Did you understand this much clearly?
Yes, doctor.
Okay, if anyone has any question, you can ask, my dear. Okay, yeah.
Doctor,
Yeah.
during the exams, are you going to tell us if the nucleophile is strong or not?
Yeah. Yes. Okay. Next is. Oh, just not this one we finished. This is not there. This we finished. No. This one, SN2 mechanism for you to tell me. Just tell me. This is what we did just now. So tell me, how will you do it? Tell me. This is that one was it was ready-made example. So here, how do you do it? Tell me.
How do you bracket?
Okay, so first of all, this is slow process. Okay, yeah. No, it's only one step, so no need to slow or fast. Okay, so you will get an intermediate. So how do you make the intermediate? Tell me.
You'll draw a bracket.
Yes.
And then we have the transition state.
Yes, we have CS3, we have H, we have C2H5. I'm not writing wedge and dash. Now something is coming inside, something is going out. So the leaving group is Br minus. And incoming group is what? OH, correct? So you get a transition state. See, okay?
There's a negative sign on the bracket.
Yeah, brackets negative sign. So that is not very significant. Next step, what will happen? The Hava is coming. You are holding the umbrella. So what will happen? Come on. So the configuration will be opposite to that of this. See, since I put CS3 straight, I'm going to keep that CS3 straight. Okay. So here I get C, CS3 up. BR is on the right side. So OH will come on the
left side.
Left side. Okay. Now this H and C2H5 are on the left side, right?
Yes.
H and C2H5 are on the left side, and so what will happen? What will happen? This dash will remain dash. Wedge also will remain wedge. Okay.
Will be on the right.
But yes, only thing is left side thing will become right side. Okay, so this is actually R, so 2-bromobutane. Okay. So if it is R, this will become, come on. If it is R, yes, you will become, you will get S. Now this is what? Butane 2 all. Instead of R, it will be S. Now it's okay for you. Okay, so it's what is happening here? Inversion, right? Inversion occurs. Oh my God, when I breathe itself, the screen is moving. Okay. So this is inversion. Okay, now this is for this is another example. Okay, so can you see this is example number 1, say example number 2. Now look at this one. This is cyclohexane. Can you tell me this is cis isomer or trans isomer?
This is
cis, because this is up.
They're both up.
This also is up, both up. So this is configuration is cis. Now, this is the nucleophile. It's a strong nucleophile. Okay, OH minus also is a strong nucleophile. Now, yeah, so the CN will approach the carbon which contains Br at an angle 180 degree. Can you see? CN is here. This is the leaving group. That's why I dotted line. This is leaving group. This is approaching this carbon at an angle 180 degree. Right? Correct?
Yes.
Okay, so now what about the CS3? This CS3 will remain the same, correct?
Yes.
And here also I forgot to write Br minus is going out. Now here also Br minus will go out. What about the position of Cn? What about the position of Cn? Tell me.
It will be down.
Yes. Oh. Okay. This is driving me crazy. Okay, so now come on. So I will get Cn down. Correct?
So it will be trans.
Yes, you see, one of the group is up, the other group is down. So this has became trans. See, this is up, this is down. So we started with cis, but at the end you got
Trans.
trans. Okay, it's clear, right? Okay.
Yes.
Only Rahma is there in the class. What about others? Munira, Talal? All are here?
Yes, yes.
Oh, okay. Did you understand all this? This all you don't have to memorize. It's so easy. Now here, mechanism of SN1. I told you, SN1 has how many steps? How many steps?
2 steps.
2 steps.
One slow and one
Step
fast.
number 1, formation of carbocations. Step 2, nucleophilic attack. All right? Okay, the slow step. Which is a slow step? This is the slow step. This is step 1. This is step 2. Fast step. This is step 2. Okay, this is OR. Can you see OR? Actually, it's not OR, it's plus. Okay, not OR. Okay. So now, first step, did you understand? First step you understood?
Yes.
Okay, before that, I just want to ask you about that. Do you remember SN2? I explained you are in the classroom at UOB. I have a chair here. One person is sitting inside. I want to replace him. Okay? Yeah?
Yes.
Okay, so
And
his
there are two
student is...
doors.
Yeah, yes, very good, Rahma. Here we have a door. This is door number 1. Here we have another door. Okay, 2 doors are there. So this we are doing in SN1 way, not SN2 way. SN2 way means same time both the people are there. One is coming in, the other one is going to go out. Now here it's not like that. Step number 1, the student who is sitting on this chair will leave the class. So now the chair is empty. Nobody is on the chair. Understand? Understood? So
Yes.
here, first step x minus has gone out. So Mafi x minus on this chair. Chair is empty. So now we
So the new
have
student
2
will come from
doors.
any door.
Yes, very good, excellent. So there are 2 possibilities. 50-50 chances. Okay, because the chair is in the middle, so student can enter through this way, or it can he can or she can enter through this way. Chance is here 50%, here also 50%. Sah? Okay, so this is what happening in SN1. Look at this one. What's happening? So this is first step, step 2. So the first step, carbocation is formed. Okay, so this is a carbocation. Same, okay? Okay, understood what I meant? Okay, so this is gone. Now this nucleophile can come either through this way. Can you see 2 possibilities? The nucleophile is coming through this way, or nucleophile can come through the opposite way. So you will get 2 structures, 2 products. One of the products, can you see in this product what is the difference? The R1, R2,
Here it's just
R3
replaced.
towards the same instead of X in U. So we call it as retention. That means same configuration. Same configuration of the reactant, correct? Correct?
Yes.
Okay. Now look at this one. Look at this one. Here, look. This R1, R2, all of them, this R2 and R3, R1 is straight, okay? And R2, here R2 and R3 towards the right, here R2 and R3 towards the left. Here X is on the left side, here NU is on the right side. So this is which one? Come on.
Inversion.
Inversion. So we have 50% inversion, takriban, okay? Always you will not get exact 50%. 50% inversion, 50% retention. So the whole thing will, we use another term for this one. 50%. Oh. So we call it as what is it called? What is it? Yes, you get a racemic mixture. Understood? So that means 50% 50% is having 50% of the product is having same configuration as that of the reactant. The other 50% is having opposite configuration. So what will happen at the end? Oh, yes, you get this. Did you get it? Understood?
Yes, doctor.
Everyone understood? Any doubt? Anyone has any question? Anyone has question?
Yeah.
Okay, no, this is what. Now I just need, okay, we have time. Okay, no questions, right? Look at this one, look at this one. Yeah, so this is an example. This is tertiary one. Can you see tertiary? Now, so this is chiral because all groups are different. So this is a weak nucleophile. Water is a weak nucleophile, okay? OH minus is strong. and Cn minus is strong. This is weak nucleophile. So H and Br form a molecule of HBr and you get alcohol. Now, come on, step number one, formation of carbocation, slow step. So how do I get, tell me? I write C, tell me, CS3. Come on.
Then you just write CH2.
C2H5. C3H7 plus, right?
Yes. And Br is outside.
Yes. Now who is coming in? OH minus. So I will get two products, right? I will
Yes.
get two products. What are the two products? Tell me. C.
Either inverted
Here
or
it is.
retention.
CH3. Yes. CH3. Then
Just
here
replace
it is.
the position of Br with OH.
Oh, okay. It should be dotted. Where is it gone? Okay. So this side it is. This side it is what? C3H7. And right side what do we have?
OH.
OH. So this is one of the products. Now I need to switch it. So I will get, come on, C, CH3.
CH3.
Now OH is on which side?
On the left.
Left side.
And then
And
CH2, C2 and C3 are going to be on the left. On the right, sorry.
okay, this is dotted. Okay, so this is what? Come on, this is what? Retention. First one, retention or inversion?
Retention. First one is
Yes,
retention.
retention.
Second one is inversion.
Inversion. So you get resume mixture. Okay. Okay. Now we need to do a little more things. You have time to sit 2 more minutes, or you have some other lecture now? Dear students.
I think some people have some. I think some people have thermodynamics now. Maybe.
Okay, so then I will leave. Okay, but then my dear, when you come next class, please revise and come. Otherwise, it's difficult. I just need to finish this slide, but then it's difficult. Okay. Please at least read one time and come, all of you. Okay. Okay then. Take care. Okay. Yeah. Okay. Stay healthy. Stay always stay healthy. Okay. Be safe. Stay healthy. Okay. Okay. Bye bye.
Have a nice day, doctor.
Yeah, you too, dear. Let me take the attendance. Just a minute. Let me take the attendance.